Hello everyone, welcome back to Educational Era. Today we'll be looking at some special cases for simple harmonic motion where we'll explore how the velocity, displacement and acceleration changes in these special cases and what will be the result of velocity, displacement and acceleration. And at the last of the video I'll make you a table so you can remember all of these special cases. And all right, so let's get going. So in this video I will take simple pendulum as an example of an harmonic oscillator. So let me just draw a simple pendulum real quick. And all right, it will not take much time. Here is our simple pendulum, right? And now we will see, first we'll see when there is no displacement. That means when theta or omega t is going to be 0. That is this case right here, when simple pendulum is not moving, rather it's in its mean position, in its fixed position, right? So first we will explore that, and then we will explore when theta or omega t is going to be maximum. That is, for now, let's say it's going to be 90 degrees, so maybe up till here. Let's suppose when it's here it's going to be 90 degrees. Let's say this 90 for example, and let's suppose this is 90 degree, and let's see what will happen when theta or omega t is going to be 90 degrees. All right, so let me just draw the simple pendulum in the next slide real quick. And all right, here is our simple pendulum. Now let me write down the equations that we explored in our previous video. So first we know that displacement is going to be r sine omega t. By the way, check our previous video if you don't know this already. And we know that velocity is derivative of this, that is r omega cos omega t. And we know that as we can write this in a different form, that is omega r square minus sine square omega t, r square sine square omega t, that is again omega r square minus y square, right? And we know that acceleration is minus omega square y. So let's use these equations and see what will be the velocity, displacement and acceleration when the body is at its mean position. So let me use a different color. All right, so let's see when theta or omega t is 0, right? Theta is 0 degrees, yes, 0 degree. So for the displacement, if you see here, sine omega t is going to be sine 0, right? So sine 0 is 0, so y should also be r into 0, that is 0. So y is r times 0, that is 0. So it doesn't cover any displacement technically. So likewise, if you see a see velocity, then cos omega t is going to be cos 0, and cos 0 is 1, so velocity is r omega times 1, that is our r omega. So it will have maximum velocity because the maximum value of cos is 1 and other two are the constant properties, and here r is amplitude, right? Likewise, let's see about acceleration. Acceleration is going to be minus omega squared y, and we know y is 0, so acceleration also is going to be 0. So this is the case when theta or omega t is going to be 0 degrees. All right, let's explore when theta or omega t is going to be maximum, or for now 90 degrees. All right, so let's say at first the theta or omega t, let's say this is our mean position, and it moves, the pendulum moves up till here, right? It moves up till here, covering a displacement of y, right? And this is going to be 90 degrees. So let's again write those equations. Y is r sine omega t, v is going to be r omega cos omega t, and acceleration is minus omega square y. Now if you look, the omega or theta is going to be 90 degrees. So now let's see what happens to y. So y is r sine omega t, and sine omega t is sine 90, that is 1. So y is going to be r times 1, that is r. So y is maximum. Likewise, velocity is going to be cos omega velocity is r omega cos omega t, and cos omega t is going to be cos 90 degree, and cos 90 degree is 1. So velocity is going to be, oh so sorry, cos 90 degree is 0, so velocity is going to be r omega times 0, that is 0. Likewise, acceleration is going to be minus omega square y, and if we replace y as r right here, then we get a is equals to minus omega square r, right? Again, r is amplitude here, not the length of the pendulum. Alright, so let me write this down in a table. Alright, so this is our table. Now if you look, this is what we discussed so far. So when theta is 0, displacement is going to be 0, acceleration is 0, and velocity is r omega, which is maximum. And when theta is 90 degrees, our displacement is going to be maximum, that is r, and our velocity is 0, and our acceleration is again going to be maximum. Well, that is all for this video. Thank you so much for watching. This is all for today. In our next video, we'll be talking about phase, time period, amplitude, and frequency. Likewise, we will also talk about energies, right? Kinetic and potential energy associated with simple harmonic motion. Yeah, so that is all. Make sure to subscribe, like this video, and thank you so much for watching.